JSON format has become the go-to standard for crafting cloud infrastructure and web application log data, largely due to its adaptability in supporting various data types. However, this versatility can complicate handling these logs. In this presentation, we'll tackle the top 3 challenges: array flattening, nested objects, and nested field analytics. Let's take a look at a sampling of the widely used AWS CloudTrail log. First, we'll dive into the concept of array flattening. Flattening arrays involves extracting and exposing inner elements for analysis. Arrays can be flattened vertically into rows or horizontally into columns. In our CloudTrail log example, there's a records array at the top level, with each element representing an individual log record. While it's straightforward to expand this vertically into new rows for each record, it gets trickier when dealing with nested arrays under request parameters and response elements. These arrays contain multiple elements, and flattening them vertically creates duplicate records, which isn't ideal for analysis. Flattening all arrays simultaneously leads to a surge in the number of rows and columns. This complicates data management, increases storage needs, and slows down processing and analysis. Moving on, we encounter the challenge of expanding nested objects. In our CloudTrail example, the detailed field contains several nested objects, forming a complex rank structure. Simply flattening these without control results in a proliferation of columns. This complicates the schema and potentially curbs the analysis and query performance. Lastly, another challenge arises when we avoid flattening but still need to perform aggregations over nested fields. Indexing nested fields as strings can be an option, but limits the ability to efficiently run aggregation analysis. For instance, running an analysis like breaking the number of API calls by username wouldn't be possible in this case if the whole user identity field is indexed as a string. Now that we understand the main challenges, let's explore how ChaosSearch's capabilities help overcome them. One key feature is the ability to flatten arrays and control nested object expansion at ingestion time. This configuration can be selected within the object group setup. ChaosSearch offers 2 options to control array expansion: vertical or horizontal mode, and the array flatten depth level. For example, we need to flatten records array, which is at the top level, so selecting array flatten with a depth of 1 and vertical expansion suits our needs. Another provided option is controlling the expansion of nested objects, such as the user identity field, using schema policies. By uploading the config file with an exclusion list, in this example, we have several nested objects. We can prevent the expansion of these objects, keeping them as strings on a single column. This helps manage schema size and avoid performance impacts due to schema explosion. We can simply drop the config file here and save it. Then, give this object a group name and start ingesting. Next, we're going to show how to run analytics over the nested objects excluded from expansion during ingestion. When you create a view and apply a transformation to one of the nested fields, let's say user identity in this case, you have the option to choose the Materialize with JSON path transformation from the list of available options. Using the standard JSON path syntax, we can specify keys and extract the values from these keys. Here we can see the original user identity field kept as a string, and a preview of the content in the materialized account ID and ARN fields. You can now use the new materialized fields for search, analytics, like this open search dashboard chart, or in SQL queries, like this example, using the superset BI tool. In summary, ChaosSearch offers robust solutions to navigate the complexities of handling messy JSON logs, providing efficient ways to ingest, manage, and analyze data, ultimately enhancing data-driven decision-making. ChaosSearch, know better.